Example 10. Bank A offers an account paying 1.2% compounded quarterly. Bank B offers an account paying 1.1% compounded monthly. Which is offering a better rate? We can compare these rates using the annual percentage yield, the actual percent increase in a year. Bank A, APY equals 1 plus 0.012 divided by 4 to the fourth power minus 1 equals 0.012054 equals 1.2054%. Bank B, APY equals 1 plus 0.011 divided by 12 to the 12th power minus 1 equals 0.011056 equals 1.1056%. Bank B's monthly compounding is not enough to catch up with Bank A's better APR. Bank A offers a better rate. A limit to compounding. As we saw earlier, the amount we earn increases as we increase the compounding frequency. The table, though, shows that the increase from annual to semi-annual compounding is larger than the increase from monthly to daily compounding. This might lead us to believe that although increasing the frequency of compounding will increase our result, there is an upper limit to this process. To see this, let us examine the value of $1 invested at 100% interest for 1 year. These values do indeed appear to be approaching an upper limit. This value ends up being so important that it gets represented by its own letter, much like how pi represents a number. Euler's number, E. E is the letter used to represent the value that 1 plus 1 over k to the k power approaches as k gets big. E is approximately 2.718282. Because E is often used as the base of an exponential, most scientific and graphing calculators have a button that can calculate powers of E, usually labeled e to the x. Some computer software instead defines a function, exponent of x, where exponent of x equals e to the x. Because E arises when time between compounds becomes very small, E allows us to define continuous growth and allows us to define a new toolkit function. F of x equals e to the x. Continuous growth formula. Continuous growth can be calculated using the formula f of x equals a e to the rx power, where a is the starting amount, r is the continuous growth rate. This type of equation is commonly used when describing quantities that change more or less continuously, like chemical reactions, growth of large populations, and radioactive decay. Example 11. Radon-222 decays at a continuous rate of 17.3% per day. How much will 100 milligrams of radon-222 decay in 3 days? Since we are given a continuous decay rate, we use the continuous growth formula. Since the substance is decaying, we know the growth rate will be negative. R equals negative 0.173. F of 3 equals 100e to the negative 0.173 multiplied by 3 power, which is approximately 59.512 milligrams of radon-222 will remain. Try it now. Interpret the following. S of t equals 20e to the 0.12 t power if S of t represents the growth of a substance in grams and time is measured in days. Continuous growth is also often applied to compound interest, allowing us to talk about continuous compounding. Example 12. If $1,000 is invested in an account earning 10% compounded continuously, find the value after 1 year. Here, the continuous growth rate is 10%, so R equals 0.10. We start with $1,000, so A equals 1,000. To find the value after 1 year, f of 1 equals 1,000e raised to the 0.10 multiplied by 1 power, which is approximately $1,105.17. Notice this is a $105.17 increase for the year. As a percent increase, this is 105.17 divided by 1,000 equals 0.10517 equals 10.517% increase over the original $1,000. Notice that this value is slightly larger than the amount generated by daily compounding in the table computed earlier. The continuous growth rate is like the nominal growth rate, or APR. It reflects the growth rate before compounding takes effect. This is different than the annual growth rate used in formula f of x equals a multiplied by 1 plus r to the x power, which is like the annual percentage yield. It reflects the actual amount the output grows in a year. While the continuous growth rate in the example above was 10%, the actual annual yield was 10.517%. This means we could write two different looking but equivalent formulas for this account's growth. F of t equals 1000e to the 0.10t power using the 10% continuous growth rate. F of t equals 1000 multiplied by 1.10517 to the t power using the 10.517% actual annual yield rate.